Before the helicopter became an instrument of combat, it existed as a solution in search of a problem. For the first half of the 20th century, war was defined by two rigid dimensions. On the ground, armies advanced at the pace of men, trucks, and tanks, constrained by terrain, roads, rivers, and weather. In the air, fixed-wing aircraft offered speed, altitude, and reach, but only in straight lines and with the constant requirement of runways and forward bases. Between these two realms lay a critical operational void, the inability to move forces vertically, to appear where roads did not exist, and to apply force with precision in places that conventional aircraft could not reach. This gap became painfully evident during World War II. Mountain ranges, dense jungles, urban ruins, and island chains exposed the limitations of traditional logistics and fire support. Armies could seize territory, but often could not hold it efficiently. Casualties mounted not only from enemy action, but from the sheer difficulty of evacuating the wounded and resupplying isolated units. The helicopter promised to change this reality. Its defining capability was not speed or altitude, but freedom. Vertical takeoff and landing meant independence from infrastructure. Hovering meant control. Low-speed maneuverability meant persistence over the battlefield. Yet these advantages came with severe compromises. Early rotary-wing aircraft were mechanically fragile, underpowered, and aerodynamically inefficient. Their engines struggled to lift their own weight, let alone weapons or armor. Vibrations threatened structural integrity. Rotor systems behaved unpredictably at the edge of their performance envelopes. For military planners in the 1940s, the helicopter was intriguing but unreliable, a niche tool rather than a decisive platform. The geopolitical environment of the early Cold War transformed that skepticism into urgency. The prospect of large-scale conventional conflict in Europe, combined with the rise of limited wars in Asia and later in the developing world, forced militaries to rethink mobility and firepower. The battlefield was no longer assumed to be linear or static. Front lines blurred. Guerrilla tactics exploited terrain and civilian cover. Rapid response, flexibility, and localized superiority became more valuable than sheer mass. In this context, the helicopter was no longer a curiosity. It was a potential solution to a systemic problem: how to project force quickly, precisely, and repeatedly in environments where traditional platforms were constrained. Early combat use during the Korean War demonstrated both promise and limitation. Helicopters evacuated wounded soldiers from forward positions in minutes rather than hours, saving thousands of lives and reshaping military medicine. They resupplied isolated units and inserted reconnaissance teams into otherwise inaccessible terrain. But when exposed to enemy fire, they revealed their vulnerability. Lightly built and unarmed, they depended entirely on speed, terrain masking, and luck. The lesson was clear. If helicopters were to operate routinely in contested airspace, they could not remain purely logistical tools. They needed protection. More importantly, they needed teeth. Transforming the helicopter into a combat platform was not a matter of simply bolting weapons onto an existing airframe. It required solving a set of engineering problems that cut across aerodynamics, propulsion, structures, and human factors. The first challenge was power. Unlike fixed-wing aircraft, helicopters must generate lift continuously, even when stationary. Every kilogram added in weapons, fuel, or armor directly reduced performance. Early piston engines lacked the power-to-weight ratios necessary for true combat survivability. The emergence of lightweight turboshaft engines in the 1950s and 1960s was therefore a turning point. These engines delivered high output with relatively low mass and could maintain performance in hot, high-altitude conditions where piston engines faltered. Equally complex was the problem of rotor dynamics. The main rotor is both wing and propeller, subjected to asymmetric airflow, cyclic loading, and intense vibration. As helicopters grew heavier and faster, rotor systems had to endure higher stresses without catastrophic failure. Engineers experimented with new materials, hub designs, and blade geometries. Fully articulated rotors improved control but added mechanical complexity. Semi-rigid and rigid systems reduced parts count but demanded more precise engineering and stronger materials. Each design choice represented a trade-off between performance, reliability, and maintainability, all under the unforgiving conditions of combat. Weapons integration introduced another layer of difficulty. Firing rockets, cannons, or missiles from a hovering or slow-moving platform generates recoil, asymmetric forces, and intense acoustic and thermal loads. These forces interact with the rotor system, avionics, and airframe in ways that are far more complex than in fixed-wing aircraft. Stabilization systems had to be developed to allow accurate fire while maneuvering. Sighting systems needed to account for aircraft motion, wind, and target movement. The helicopter pilot, already managing a demanding flight regime, now had to function as a weapons operator, often at low altitude and under fire. This reality drove innovations in crew configuration, leading to tandem cockpits and the division of tasks between pilot and gunner. The financial and political risks associated with this transformation were substantial. Developing a purpose-built attack helicopter required long timelines, high costs, and a willingness to challenge established doctrines. Critics argued that helicopters would never survive against modern air defenses, that they were too slow, too fragile, and too expensive for the firepower they delivered. Proponents countered that no other platform could combine persistence, precision, and responsiveness at the tactical level. The debate was not merely technical, it was institutional. Armies and air forces had to redefine roles, command structures, and procurement priorities. The crucible in which these arguments were tested was Vietnam. Dense jungle, dispersed enemy forces, and the absence of clear front lines created an environment tailor-made for rotary-wing operations. Armed helicopters evolved rapidly from improvisation to necessity. Door gunners, rocket pods, and forward-firing weapons transformed transport helicopters into ad hoc gunships. These aircraft escorted troop insertions, suppressed enemy fire, and provided immediate support to units in contact. The psychological effect was profound. The helicopter became both lifeline and guardian, its distinctive sound signaling either rescue or imminent attack. From this experience emerged the concept of the dedicated attack helicopter. No longer a modified transport, this new class of aircraft was designed from the outset to fight. Its airframe was narrow and armored. Its cockpit was optimized for target acquisition and survivability. Its weapons were integrated into a coherent fire control system. The first generation of such helicopters demonstrated that rotary-wing aircraft could not only survive on the modern battlefield, but dominate specific tactical niches. They hunted armored vehicles, provided overwatch for maneuvering forces, and operated in weather and terrain that grounded fixed-wing support. Quantitatively, the impact was measurable. A single attack helicopter unit could cover vast areas, respond within minutes, and deliver precision fire at a fraction of the cost of deploying additional ground forces or fast jets. Their ability to loiter meant sustained presence rather than fleeting strikes. Operational commanders gained a tool that compressed time and space, altering the tempo of engagements. The battlefield became more fluid, more vertical, and more dynamic. As these aircraft matured, their influence spread globally. Other nations adapted the concept to their own doctrines, environments, and industrial capabilities. Some emphasized anti-armor warfare, integrating advanced guided missiles capable of defeating the heaviest tanks at standoff ranges. Others focused on counterinsurgency, prioritizing endurance, sensor coverage, and the ability to discriminate targets in complex environments. Despite these differences, the underlying design philosophy remained consistent, a balance of firepower, survivability, and agility, constrained by the unforgiving physics of vertical flight. Technological evolution did not stop with the airframe. Advances in avionics transformed the attack helicopter into a networked node on the battlefield. Night vision systems, thermal imaging, laser rangefinders, and helmet-mounted displays allowed crews to fight effectively in darkness and poor weather. Data links connected helicopters to ground units, drones, and command centers, enabling coordinated operations and rapid decision-making. These systems reduced pilot workload while increasing lethality, a critical factor in an environment where seconds often separate success from disaster. Survivability drove further innovation. Redundant systems ensured that damage did not immediately translate into loss. Self-sealing fuel tanks, crash-worthy structures, and armored crew compartments improved the odds of survival under fire. Infrared suppressors and countermeasure systems reduced vulnerability to heat-seeking missiles. Tactical doctrines evolved in parallel, emphasizing terrain masking, pop-up attacks, and coordinated maneuver to minimize exposure. The helicopter was no longer merely flying low. It was exploiting the three-dimensional battle space with deliberate intent. Over time, the influence of combat helicopters extended beyond the military sphere. Their development accelerated advances in materials science, control systems, and propulsion that filtered into civilian aviation. Emergency medical services, offshore operations, and disaster response benefited from technologies originally designed for survival and precision in combat. Economically, the industries that supported helicopter production created skilled jobs, export opportunities, and long-term technological ecosystems. Politically, the possession of advanced attack helicopters became a marker of military capability, shaping regional balances of power and defense relationships. Culturally, the attack helicopter emerged as an icon of modern warfare. Its silhouette, aggressive and unmistakable, symbolized a new form of power projection, intimate, persistent, and close to the ground. Unlike high-altitude bombers or supersonic fighters, the helicopter was seen and heard by those it affected. This proximity shaped public perception, embedding the aircraft in films, literature, and collective memory as both protector and predator. The legacy of combat helicopter development is therefore not confined to any single model or conflict. It lies in the demonstration that engineering ambition, when guided by operational necessity, can redefine what is possible. Designers confronted the inherent inefficiencies of rotary-wing flight and transformed them into advantages. Militaries accepted the risks of innovation and reaped the rewards of flexibility and responsiveness. The result was a platform that reshaped tactics, saved lives, and altered the economics of force projection. Today, as unmanned systems and advanced sensors redefine the future of warfare, the combat helicopter continues to evolve rather than disappear. New designs integrate reduced signatures, improved networking, and manned-unmanned teaming, ensuring relevance in increasingly contested environments. The core challenge remains unchanged, balancing power, protection, and agility within the limits imposed by physics. Each generation builds upon the lessons of the last, refining a concept born from necessity and sustained by ingenuity. In the final analysis, the development of combat helicopters stands as a testament to human determination to overcome constraints. It reflects a willingness to confront complexity, accept risk, and pursue solutions that defy conventional wisdom. The helicopter did not replace tanks, infantry, or fixed-wing aircraft. It complemented them, filling a critical gap and creating new possibilities. Its story is one of adaptation, persistence, and vision. And in that story lies a broader truth about aviation itself. The history of flight is not merely a record of machines, but of minds willing to challenge limits. The history of aviation is written with steel, ingenuity, and the will to defy boundaries. As combat helicopters matured from experimental concepts into operational necessities, their continued development became a relentless exercise in systems integration rather than isolated breakthroughs. The fundamental challenge was no longer proving that an armed helicopter could survive on the battlefield, but ensuring that it could dominate increasingly complex threat environments. The modern battlefield evolved faster than any single platform, forcing helicopter designers to think not in terms of individual aircraft, but as elements within a wider combat ecosystem. One of the most decisive shifts was the rise of armored warfare as a primary mission driver. During the Cold War, massive tank formations represented the backbone of conventional military power, particularly in Europe. Fixed-wing aircraft could strike these formations, but only episodically and often at high risk from air defenses. The helicopter, operating close to the ground, offered a radically different approach. By exploiting terrain masking and pop-up attack profiles, it could engage armored targets from unexpected angles, retreat, reposition, and strike again. This capability fundamentally altered ground warfare calculations, forcing tank designers and tacticians to account for a threat that came not from the sky above, but from the horizon itself. Engineering such capability required unprecedented precision in weapons integration. Anti-armor guided missiles had to be accurate, reliable, and usable from a vibrating, maneuvering platform. Early wire-guided systems demanded intense pilot concentration, effectively tethering the helicopter to its target for the duration of missile flight. This constraint drove further innovation in stabilization, optics, and eventually fire-and-forget technologies. Each advancement reduced exposure time, improved survivability, and increased lethality, reinforcing the helicopter's role as a decisive anti-armor asset. At the same time, avionics underwent a quiet revolution. Early combat helicopters relied heavily on pilot skill and visual cues. As missions expanded into night and adverse weather, this reliance became a liability. The integration of thermal imaging and low-light sensors transformed operations, allowing helicopters to detect and engage targets long before being seen themselves. This sensory advantage compressed the decision cycle, enabling crews to observe, orient, decide, and act faster than their adversaries. In warfare, this temporal edge often proved more decisive than raw firepower. Human factors engineering became equally critical. The cognitive load placed on helicopter crews was immense. Flying at low altitude, navigating complex terrain, monitoring sensors, communicating with ground units, and engaging targets simultaneously pushed human performance to its limits. Designers responded by rethinking cockpit layouts, display hierarchies, and control ergonomics. Information was no longer merely presented, it was curated. The goal was not to give crews more data, but better understanding. This shift marked a broader transition in military aviation from platform-centric design to human system integration. The economic implications of combat helicopter development were significant and often underestimated. Unlike fast jets, which typically serve a single air force and operate from centralized bases, helicopters are distributed assets. They require extensive maintenance infrastructure, training pipelines, and logistical support close to the front lines. This created sustained demand for skilled technicians, spare parts, and specialized facilities. Entire industrial ecosystems grew around rotorcraft production and support, generating long-term economic impact that extended well beyond initial procurement costs. Politically, the spread of attack helicopters reshaped military relationships. Nations capable of producing or acquiring advanced combat helicopters gained not only battlefield capability, but strategic leverage. Export variants became tools of diplomacy, defense cooperation, and influence. At the same time, proliferation raised concerns about regional stability, as the introduction of attack helicopters could dramatically shift local balances of power. This dual-use nature, both stabilizing and destabilizing, reflected the broader paradox of military technology in the modern era. Combat experience continued to refine design priorities. Conflicts in the late 20th and early 21st centuries demonstrated that helicopters were not solely tools of high-intensity warfare. They proved equally valuable in counterinsurgency, peacekeeping, and asymmetric conflicts. In these environments, discrimination and restraint became as important as firepower. Precision-guided weapons reduced collateral damage, while improved sensors allowed crews to positively identify targets before engagement. The helicopter's ability to loiter and observe made it as much an intelligence platform as a strike asset. This adaptability reinforced the helicopter's strategic value. While fixed-wing aircraft excelled at rapid, large-scale strikes, helicopters offered persistence and presence. They could shape the battle space over hours rather than minutes, responding dynamically to unfolding situations. This persistence altered command philosophies, encouraging decentralized decision-making and closer integration between air and ground elements. The helicopter became not just a tool of command, but an extension of it. Technological convergence further expanded these roles. Advances in digital communications linked helicopters into broader command and control networks. Real-time data sharing allowed them to coordinate with unmanned systems, artillery units, and ground patrols. This networking reduced redundancy, increased situational awareness, and enabled more efficient use of force. The helicopter evolved from a standalone platform into a node within a complex, adaptive system. Yet every advance introduced new vulnerabilities. As helicopters became more reliant on electronics and networks, They faced threats not only from bullets and missiles, but from electronic warfare and cyber disruption. Designers responded by hardening systems, adding redundancy, and developing tactics to operate in degraded environments. This constant interplay between capability and vulnerability underscored a central truth of combat helicopter development. There is no final solution, only continuous adaptation. The cultural impact of these machines persisted alongside their technical evolution. For the crews who flew them, combat helicopters demanded a unique blend of skill, discipline, and courage. Pilots operated at the edge of controlled flight, often within visual range of enemy forces. Their experiences shaped training cultures and institutional identities, reinforcing the perception of helicopter units as elite, tightly bonded communities within larger military organizations. As the decades progressed, the attack helicopter's design philosophy crystallized into a set of enduring principles. Survivability through redundancy, lethality through precision, and effectiveness through integration became guiding tenets. New materials reduced weight while increasing strength. Composite rotor blades improved performance and damage tolerance. Modular avionics allowed upgrades without complete redesigns, extending service lives and preserving investment. By the early 21st century, the attack helicopter stood as a mature yet evolving system. It had proven its worth across diverse conflicts, climates, and missions. Its presence influenced adversary behavior, forcing changes in tactics, force structure, and defensive investments. Even when not employed, the mere possibility of helicopter intervention shaped operational planning on both sides of a conflict. This enduring relevance set the stage for the next phase of evolution. As emerging technologies such as automation, artificial intelligence, and unmanned teaming began to redefine warfare, the helicopter faced another inflection point. Its future would depend not on abandoning its core strengths, but on integrating them with new concepts of operation. The story of the combat helicopter thus remained unfinished, defined by continuous refinement rather than obsolescence. What had begun as an attempt to fill a logistical gap had become a cornerstone of modern military power. Through decades of engineering effort, operational testing, and hard-earned lessons, the combat helicopter evolved into a platform that reshaped how wars are fought. Its journey illustrated a fundamental principle of aviation history: that true innovation is rarely linear, but forged through persistent adaptation to real-world demands. The next stage in this evolution unfolded as combat helicopters confronted the realities of a rapidly changing strategic environment. By the early 21st century, the battlefield had become saturated with sensors, precision weapons, and layered air defenses. What once relied primarily on terrain masking and low-altitude flight now demanded a deeper integration of intelligence, timing, and coordination. The helicopter's continued relevance depended on its ability to operate not just in permissive or semi-permissive environments, but in contested spaces where detection could be instantaneous and lethal. This pressure accelerated innovation in survivability and signature management. Designers recognized that avoiding detection was often more effective than defeating threats directly. Radar cross-section reduction, infrared signature suppression, and acoustic management became critical areas of research. Engine exhausts were reshaped and cooled to reduce heat signatures. Airframes incorporated materials and geometries that scattered radar energy. Even rotor blade design was refined to minimize acoustic footprints, delaying detection and complicating enemy targeting. These measures did not render helicopters invisible, but they extended the margin between detection and engagement, buying crews precious seconds to maneuver or strike. Weapons philosophy evolved in parallel. The emphasis shifted from direct exposure to standoff engagement. Modern guided missiles allowed helicopters to strike targets from beyond the effective range of many air defense systems. Fire and forget capabilities reduced the need for sustained target illumination, enabling rapid disengagement after launch. This shift transformed tactics. Helicopters no longer needed to hover aggressively over the battlefield. They could exploit fleeting windows of opportunity, appearing briefly, delivering decisive force, and disappearing before counterfire could be organized. At the same time, the integration of digital battle management systems redefined how helicopters were employed within joint operations. crews gained access to real-time intelligence feeds, shared targeting data, and coordinated strike planning. This connectivity blurred traditional service boundaries. Helicopters worked seamlessly with fixed-wing aircraft, unmanned aerial systems, and ground-based fires. The result was a layered approach to combat, where each platform amplified the effectiveness of the others. In this environment, the helicopter's value lay not only in what it could destroy, but in how it contributed to the collective understanding of the battle space. Training doctrines adapted accordingly. Crews were no longer trained solely as pilots and gunners, but as battlefield managers. Decision-making under uncertainty became a core competency. Simulators grew more sophisticated, replicating complex threat environments and networked operations. These tools reduced risk during training while preparing crews for scenarios that would have been impossible to rehearse safely in the real world. The human element remained central, but it was now augmented by systems designed to enhance perception, judgment, and coordination. The economic dimension of this evolution remained substantial. Sustaining advanced combat helicopters required continuous investment, not just in hardware, but in software, upgrades, and lifecycle support. Modernization programs extended service lives while incorporating new capabilities, balancing cost with operational necessity. This approach reflected a broader shift in defense economics, where adaptability and upgrade potential became as important as initial performance. Helicopters were no longer static products. They were evolving platforms, shaped over decades by incremental innovation. Operational experience in diverse theaters reinforced these priorities. In arid deserts, helicopters contended with extreme heat and dust, testing engine resilience and filtration systems. In mountainous regions, high-altitude performance and payload margins were pushed to their limits. Urban operations introduced new complexities, from cluttered sensor environments to the constant presence of civilians. Each context fed back into design and doctrine, ensuring that future iterations addressed real-world challenges rather than theoretical assumptions. Despite these advances, the fundamental appeal of the combat helicopter remained unchanged. It offered commanders a uniquely flexible tool, capable of responding to unpredictable situations with speed and precision. Its ability to operate close to friendly forces fostered trust and integration unmatched by other air assets. This proximity, however, also carried psychological weight. Crews operated with an acute awareness of risk, knowing that their survival often depended on split-second decisions and the reliability of complex systems. As new technologies emerged, particularly unmanned and optionally piloted systems, debates intensified about the helicopter's long-term role. Some argued that unmanned platforms would eventually assume the most dangerous missions, reducing risk to human crews. Others contended that the adaptability, judgment, and situational awareness of human pilots remained irreplaceable, especially in complex environments. The resulting consensus favored integration rather than replacement. Manned helicopters began to operate alongside unmanned systems, using them as scouts, decoys, or force multipliers. This teaming concept extended reach and awareness while preserving human decision-making at the center of lethal action. The broader influence of combat helicopter development continued to ripple outward. Advances in fly-by-wire controls, vibration reduction, and composite structures found applications across aviation. Civilian rotorcraft benefited from improved safety, efficiency, and comfort, illustrating how military innovation often drives progress beyond its original context. The helicopter's journey from fragile experiment to robust combat system thus contributed to technological growth far beyond the battlefield. By this stage in its evolution, the combat helicopter had proven not only its tactical value, but its strategic adaptability. It had survived waves of technological disruption and doctrinal skepticism by continuously redefining its role. Rather than being rendered obsolete by new threats, it absorbed lessons and emerged more capable. This resilience underscored a defining characteristic of rotary-wing aviation, its capacity to evolve through integration rather than replacement. The story approaching its conclusion is therefore not one of decline, but of continuity. The combat helicopter stands as a living system, shaped by decades of engineering refinement and operational experience. Its future trajectory will be influenced by automation, artificial intelligence, and new materials, but its core purpose remains intact. It exists to operate where other aircraft cannot, to deliver force with precision and persistence, and to bridge the enduring gap between air and ground. In reflecting on this progression, one truth becomes clear. The development of combat helicopters is not merely a chapter in military history, but a case study in how technology adapts to human need. Each generation reflects the pressures, fears, and ambitions of its time. Through conflict and innovation, the helicopter has become more than a machine. It is a symbol of how engineering responds to necessity, reshaping the very nature of warfare and redefining what is possible when limits are challenged. As the combat helicopter entered the most recent phase of its evolution, its role was no longer defined solely by firepower or survivability, but by influence. Decades of operational use had proven that rotary-wing combat platforms were not transient solutions tied to a specific era or conflict, but adaptable systems capable of reshaping military thinking over generations. Their legacy became visible not just in newer helicopter designs, but across the entire spectrum of modern warfare. One of the most profound influences lay in how combat helicopters changed the relationship between air power and ground maneuver. Traditionally, air power had been centralized, episodic, and often detached from the immediate realities faced by soldiers on the ground. The helicopter dissolved that separation. It embedded air power directly into land operations, forcing doctrinal integration at every level of command. This integration reshaped how armies planned offensives, defended territory, and responded to crises. Ground units began to maneuver with the expectation of immediate aerial support, while air crews trained with an intimate understanding of infantry tactics, armored movement, and battlefield geometry. Design evolution mirrored this doctrinal shift. Later generation combat helicopters emphasized modularity and growth potential. Airframes were engineered to accept new sensors, weapons, and software without fundamental redesign. This approach acknowledged a central reality of modern conflict. Threats evolve faster than platforms can be replaced. By enabling incremental upgrades, designers ensured that helicopters could remain relevant across multiple decades, adapting to new missions and adversaries with manageable cost and risk. The influence of combat helicopter development extended deeply into systems engineering. Redundancy management, once a niche concern, became a defining principle. Lessons learned from helicopters operating under fire informed broader military design philosophies, emphasizing graceful degradation rather than binary failure. An aircraft no longer needed to be undamaged to remain effective. It needed to remain controllable, communicative, and lethal even after sustaining hits. This mindset spread beyond aviation into ground vehicles, naval platforms, and even space systems, reinforcing a resilience-focused approach to engineering. Operational experience also reshaped global military training cultures. Helicopter crews were trained to operate autonomously yet collaboratively, balancing initiative with coordination. This duality influenced broader command philosophies, encouraging decentralized decision-making supported by robust communication networks. The helicopter thus became both a product and a driver of mission command, a concept that prioritizes intent over rigid control and empowers individuals closest to the problem to act decisively. Economically, the long-term sustainment of combat helicopters created enduring industrial ecosystems. Maintenance, modernization, and training became continuous processes rather than episodic events. This sustained demand supported high-skill employment, research and development pipelines, and export markets. For many nations, participation in helicopter programs represented not only military capability, but industrial sovereignty, reinforcing domestic technological competence and strategic autonomy. Culturally, the combat helicopter's legacy is inseparable from the image it projects. Its presence on the battlefield is immediate and visceral. Unlike high-altitude aircraft, helicopters are seen, heard, and felt. This proximity has shaped both friendly and adversary perceptions. For friendly forces, the helicopter symbolizes protection and responsiveness. For opponents, it represents reach and inevitability. This psychological dimension, while intangible, has had measurable effects on morale, deterrence, and behavior in conflict zones. The evolution of the combat helicopter also influenced how militaries approach joint and coalition warfare. Shared platforms and interoperable systems facilitated multinational operations, enabling forces from different nations to operate together with common tactics and expectations. Helicopters often served as the connective tissue in these operations, bridging gaps between disparate units and command structures. Their flexibility made them indispensable in humanitarian missions, peacekeeping operations, and disaster response, further expanding their influence beyond conventional combat. Technologically, the legacy of combat helicopters is embedded in the convergence of manned and unmanned systems. The experience gained from decades of low-altitude, high-risk operations informed the development of autonomous capabilities designed to extend reach and reduce exposure. Rather than replacing helicopters, these technologies augmented them, reinforcing a hybrid approach that leverages both human judgment and machine persistence. This evolution reflects a broader lesson learned from helicopter history. Adaptability is achieved through integration, not abandonment. As warfare continues to evolve, the combat helicopter stands as a benchmark against which new concepts are measured. Its ability to combine endurance, precision, and proximity remains difficult to replicate. Even as new platforms emerge, they are often judged by how effectively they can perform the missions helicopters have long mastered. This enduring relevance underscores the depth of the helicopter's influence on military thought and design. The story at this stage is not one of stagnation, but of maturation. The combat helicopter has transitioned from revolutionary innovation to established cornerstone, shaping doctrine, technology, and culture in lasting ways. Its legacy is visible in every modern battlefield where flexibility, integration, and rapid response are paramount. Through decades of evolution, it has proven that enduring impact arises not from singular breakthroughs, but from sustained commitment to refinement, learning, and adaptation. What remains is not a finished chapter, but an ongoing narrative. The combat helicopter continues to evolve, carrying forward lessons forged under fire and refined through experience. Its influence extends far beyond its rotors and weapons, reaching into the very fabric of modern military systems. In this enduring legacy lies a powerful reminder. Aviation advances not only by reaching higher or faster, but by understanding the human problems it exists to solve. The final measure of the combat helicopter is not found in a single battle, a single airframe, or even a single generation of technology. It is found in the logic that justified its creation and the consistency with which that logic has proven valid across decades of conflict. The combat helicopter was never conceived as an indulgence of technological ambition. It was born from a practical human problem, the need to project force, protection, and awareness into spaces where traditional systems failed. Mountains, jungles, cities, deserts, and fractured front lines demanded a machine that could move vertically, linger patiently, and act decisively. That demand has not disappeared. It has intensified. From its earliest days, the helicopter challenged the dominant assumptions of warfare. Speed had long been equated with survivability, altitude with safety, and mass with effectiveness. The combat helicopter inverted these principles. It traded speed for persistence, altitude for proximity, and mass for precision. In doing so, it revealed a deeper truth about modern conflict. Control is often achieved not by overwhelming force, but by timely, informed, and sustained presence. The helicopter did not seek to dominate the sky. It sought to shape the fight at the point where outcomes were decided. This philosophy reshaped how commanders understood time and space on the battlefield. The helicopter compressed distance, turning hours into minutes. It erased natural obstacles, transforming rivers, ridgelines, and urban density from barriers into navigable terrain. More importantly, it altered decision-making cycles. With persistent aerial overwatch and immediate response capability, commanders could act with greater confidence and flexibility. Plans no longer relied solely on prearranged fire support or rigid timelines. They evolved dynamically, informed by real-time observation and rapid intervention. The engineering journey that enabled this transformation stands as one of the most disciplined examples of innovation in aviation history. Designers did not chase perfection. They pursued survivability through resilience. They accepted that helicopters would be hit, stressed, and degraded, and built systems that could endure those realities. Redundancy was not excess, but necessity. Armor was not invincibility, but time. Precision was not about destruction alone, but discrimination. Every design decision reflected an understanding that combat is chaotic, unforgiving, and indifferent to theoretical elegance. Equally important was the recognition that technology alone could not define success. The combat helicopter forced a re-evaluation of the relationship between humans and machines. Pilots and crew members were not passive operators. They were active participants in a tightly coupled system. Their perception, judgment, and coordination were as critical as any sensor or weapon. This realization drove advances in human-centered design, training, and doctrine. The helicopter became a platform that amplified human capability rather than attempting to replace it. Socioeconomic impact followed naturally from this sustained relevance. Unlike short-lived weapons systems, combat helicopters demanded continuous investment over long service lives. Maintenance, upgrades, training, and operational support created enduring industrial ecosystems. Skilled labor, specialized manufacturing, and advanced research became persistent features rather than temporary projects. The benefits extended beyond military boundaries. Technologies developed to improve survivability, reliability, and control filtered into civilian aviation, emergency services, and industrial applications. The helicopter's combat-driven evolution thus generated value far beyond its original purpose. Culturally, the combat helicopter carved out a unique place in the collective understanding of modern warfare. Its presence is immediate and unmistakable. It is seen at eye level, heard before it arrives, and felt as it hovers close to the ground. This proximity shaped perceptions on all sides of a conflict. For friendly forces, the helicopter represented reassurance and responsiveness, a tangible sign that support was not distant or abstract. For adversaries, it embodied reach and persistence, a reminder that concealment was temporary and movement observed. This psychological dimension, though intangible, proved as influential as physical firepower. The helicopter's legacy is also inseparable from its adaptability. Time and again, predictions of obsolescence emerged as new threats appeared. Air defense systems grew more lethal. Precision weapons proliferated. Unmanned platforms promised persistence without risk to human crews. Yet the helicopter endured by evolving. It absorbed new technologies rather than being displaced by them. Networking, automation, advanced sensors, and unmanned teaming extended its capabilities without erasing its core identity. This pattern revealed a central lesson. Systems designed with adaptability at their core are not rendered obsolete by change. They are refined by it. Looking forward, the future of combat helicopters will not be defined by a single breakthrough, but by continuity. Emerging technologies will reshape how these aircraft operate, how crews interact with information, and how risk is managed. Automation will reduce workload, artificial intelligence will assist decision-making, and unmanned systems will extend reach and awareness. Yet the essential role of the helicopter will remain grounded in human judgment. Complex environments, ambiguous threats, and moral responsibility ensure that accountability cannot be fully delegated to machines. The helicopter's future lies in empowering humans, not removing them. This enduring relevance underscores why the combat helicopter occupies a singular position in aviation history. It represents an engineering response to reality rather than aspiration alone. It demonstrates that progress is not always measured in greater speed or higher altitude, but in relevance sustained across changing conditions. The helicopter succeeded because it was designed to solve real problems under real constraints, and because its designers accepted that those problems would evolve. In reflecting on the full arc of its development, the combat helicopter emerges as more than a weapons system. It is a narrative of adaptation, resilience, and disciplined ambition. It shows how necessity shapes innovation, how failure informs design, and how integration multiplies effectiveness. Its story is not defined by a final form, but by a process of continuous refinement driven by operational truth. The journey of the combat helicopter, therefore, closes not with an endpoint, but with an understanding. As long as conflict occurs in complex terrain, as long as forces require immediate and precise support, and as long as human judgment remains central to warfare, the helicopter will retain its purpose. It will change in form, capability, and integration, but its essence will persist. The history of aviation is not written solely by the fastest or the highest, but by those machines that endure because they matter. The history of aviation is written with steel, ingenuity, and the will to challenge limits.